ওবিএস মিনিমাইজ করে দিয়েছি, এটাকে ফুল স্ক্রিন করব। দাঁড়াও একটু, একটু দাঁড়াও, বাকিগুলো কেটে দিচ্ছি। আচ্ছা, সাইড থেকে তোমার কিন্তু চ্যাটসগুলো ঢুকতে থাকবে কিন্তু, মানে ওপর থেকে যে চ্যাটে যেগুলো লিখবে সেগুলো তো দেখা মানে আসবে। ক্লোজ করে দিয়েছি চ্যাট বক্স। ঠিক আছে, দেখো একবার, যা আমি করে দিয়েছি, মানে আর ল্যাপটপে হাত দেবো না, তাই তো? ওকে। তুমি খুলে দেখো না। আমি তাহলে ব্যাক করে একবার কিছু দেখবো, না এরকম যেরকম আছে এরকম? ওকে, না লাইভ স্ট্রিমিং একটাতে আছে এক্সিলেন্ট কানেকশন, এখানে তো স্টার্ট হয়ে গেছে স্ট্রিমিং, এন্ড স্ট্রিমের অপশন দেখতে পাচ্ছি। এই যেখানটাতে চালু হয়ে গেছে, এখানে স্ট্রিমিং স্ট্রিমিং চালু হয়ে গেছে। হুম। হ্যাঁ। কিভাবে অফ করব?
Snehashi, just check your WhatsApp. I have forwarded you the link of today's session.
Okay. Are you ready to go live?
Yeah, almost.
Snehashish, you can start in 2-3 minutes after people join.
Hello.
Yeah.
Yeah. Should I start?
Um, Sujit, can you start? Just wait a minute.
Okay.
Yes, 31 is live now, so let it be more than 80 and we can start.
Okay. Okay. Let's just wait for some more. Srijit, if you can just put it into the full screen mode. I mean, the my screen is very showing very little because of the sidebar. Can we do something about it?
Okay, Snesh, you can start now. But your voice is a bit. Should I say it's just nobody can hear it. So can you speak a little bit louder?
Is it
Yeah,
fine
yeah,
now?
yeah, yeah. It's absolutely fine now.
Okay. Okay. So, hello everyone. Mm, Welcome back to this webinar hands-on workshop. Uh, we will start where we left off yesterday, and that is essentially the exploratory data analysis that we will do from where we uh, left off. So, the 911 call data that we were taking a dig into. Let's just take a brief recap before we proceed. Okay, so what we did yesterday was we just introduced what is machine learning and data science, and as many of you were unaware of Python, so we had to undergo the installation process of Python and Anaconda. Then we started talking about what is data science, the key features, the key steps of data science pipeline, that is objective identification, then data collection, then data mining, and data cleaning, pre-processing. Then we do the EDA, that is exploratory data analysis. Then after the EDA is done, then we move on to the model design and evaluation, and that is an iterative process as we discussed. So let me just share the slide with you. So it will be very helpful. Uh, okay. So this was the slide. The problem objective: data collection, data cleaning, exploratory data analysis, model design and evaluation, and deployment. So these are the uh, basic steps to build the data science life cycle. Then we move to what is machine learning. Uh, the types of machine learning we discussed: supervised, unsupervised, semi-supervised, reinforcement learning, and deep learning. Okay, so in these we discussed and we talked about what we will be focusing on this workshop, especially that is supervised learning. Okay, and then we moved on to something called exploratory data analysis. So this part we focused yesterday. So in that part, we took up a database, data set, and that is a 911 emergency call, and we did a little bit of exploration with that data, which we will continue today. Okay, so let me just put it back to that screen. Yeah. So now let's come to the data and let's see what we did yesterday very briefly. So that is my data 911 call. It consists of these many columns initially. So latitude, longitude, description, zip code, title, timestamp, TWP, that is township, then the address, and a dummy variable. Okay, so during this thing, during analysis, we just saw first the brief introduction, what the data looks like, and this is this is the source of the data. You can always go and download it from Kaggle. Okay, so this is where we downloaded it also, and then we moved on to the process. So we imported pandas and numpy, and also we imported matplotlib and seaborn libraries. These are the essential libraries which helps for data exploration. uh, then we just read the data. So this is a CSV file, so we read it using read underscore CSV, that is in panda. That functionality is given in pandas. So pandas is called as PD here, so that is the short form we used. That is the common notation to use pandas PD. And then we passed on the path, the entire path of the CSV file. Okay, so we can do it in two ways. As we if you can remember, we can pass on the entire path and put an R in front of it. So the R represents the raw file, so it will take it as a string and finds that path into your local machine. Okay, then after the data is read, so let's just run it. uh, I guess I just replaced the data. Just hold on a second. Let me see if I just move the data from that particular path. So that is the archive. Okay, uh, I eventually deleted the folder. Let me see if I have this data here. uh, no, so just let's just upload the data, or just uh, I changed the data path there in my local machine, so that's why it was unable to find. So let's just run it again. Now, as you can see, there is no error. The data is read. So I moved this data to this location, desktop.content. Then we check the info of the data. So that is, we stored the data in the variable called df, and we check the information about the data. So this is the information about the data. So if you just run it, these are the essential information: the columns, uh, the data type, and all the information is represented here. Then if you had to check it, what the data looks like, so we just pass the command df.head, which displays the top 5 rows of a data set. Okay, so now if you want to see it like 10 rows, you can just type 10, so it will display the 10 rows, like that. Then what we did, went through what were the 5 top zip codes from where the calls has been generated. So for that we just did the value count and put dot head, so that displayed the top 5 values of zip code values. So these are the zip codes uh, from where uh, the 911 calls were received most of the time. And then we did same with the townships, so which townships had the most number of 911 calls. Then we went on to count what are the unique titles we have in our data set. So this is the title, so these are the titles. So how many unique titles do we have in the entire data set? To find that, we just type in df and then pass on the column we want to find the unique values, then type dot n unique method. Okay, uh, there is another way, if you can remember. If I just okay, just let's first run it. So this is 148, and the other way around is just put a length. So if you put a length, len is a short form of length. So if we put a len command, it will essentially count the length of the input argument. Okay, whatever input argument inside the length. Okay, so this is a 148. Okay, then we moved on to the creating new features. So in new features, we introduced what is lambda function. Uh, that is an arbitrary function. So we tried to extract this information like EMS, fire. Okay, these are the cause of the calls. Okay, so we want to see what are the cause. So we want to extract this part, the part before the colon. Okay, so we did that to apply lambda. Then we split the entire uh, this is the entire title. We split the title using the delimiter colon. So wherever colon occurs, the sentence will be splitted. So it occurs once, so it will be splitted into 2 parts. One is EMS, one is the rest of the part, right? So then from that splitted list, we took the 0th element. So every time the 0th element will be the first element, which is EMS or fire in this case. So if you take the 0th element, we essentially take the reason of the call. So that's how we extract the reason, and then we create a new column, naming a new column in the same data file df, and put it inside that column. So we declared reason as a column, and in that column we applied that lambda function. So this way we created, if you can see here, the reason column, right? Then the next thing we did is, what is the most common reason for 911 call based on this column, based on this new column. So we want to see for which reason most of the calls occurred. So that is very simple. Dot value counts, we could have put head here also. If we just run it, uh, okay, what happened? Okay, so if we just run it, so you see that there is no difference, because there is only three different reason, because of what the call appeared. So if I put head essentially displays top 5, so it is only 3, so it makes no difference. So we avoided that. If there is number of reasons because of what the call has happened, we could have put a head, right? Then we went on to plot this table, the EMS traffic and fire. We visualized it using Seaborn, that is SNS, the short form of Seaborn. We have introduced it. In that case, that is a count plot, which essentially counts the number of occurrence of a element inside a column. The X is in which column it will count. It is the reason column, and where the reason column is situated, the data file is DF, right? And the palette here is the uh, color sequence or color palette you want to choose to display this. If you just change it here, like cool, warm, I guess there is another um, palette. Okay, so it will change. So likewise, I prefer Viridis, so I will put it back to Viridis. So we did that. Then what we did, we just took the timestamp column and did some analysis on this. So essentially, the timestamp column, although it looks like numerical value, but it is, if we checked here, the type of the timestamp column. So how we check it? We call the column, then we take any index location, that is ILOC is stands for the index location. We take any index location. For 100, we took 100 last time. Let's take one, the second index, the and what is the type of the element in the second index of timestamp column. So if I run it, it says string. So although it looks like a numerical value, it is essentially a string here. So now what we did, we converted it to a date time. Okay, so what is the date time? Date time is an object using which pandas understand that this is no more a string, this is a date time, this value corresponds to date time. So if panda understand this is a date time, so we can extract any information from it. It means like which day the call has been generated, which month, which year, at what hour, what minute, like that stuff. So we displayed it here. uh, if you do time is equals to any one sample we took, the zeroth sample, and we displayed time, that variable stored in a variable, and displayed the hour part. So it is a 12th hour. So if you see here, that is a mm, the zeroth timestamp. Okay, if I take zeroth timestamp, mm, wait. Okay, let's just first convert it. I convert it into this timestamp, and let's just run it. So this is a 17th hour. Okay, you see, this is the 17th hour. Now what we did, we applied lambda again and extract these information, the hour, the month, and the day of week. And using that, we created 3 more new columns. Okay, so we created uh, hour, month, and day of week, 3 new column, and put those information from the timestamp into that data set. Okay, so how did we do that? We declared a new column name called hour. Then we put timestamp, we take timestamp column, and we applied lambda. How? We grabbed each element, we named it as time, and we uh, called time dot hour from that time element. So it applied on entire timestamp column, and whatever the output of this function, it's stored in this column, the new column hour. Okay, likewise we did month and day of week. Okay, so now if I do this, it is processing, and if I display it df.head, let's see what happens. You see, uh, so these are the new three new columns that has been added, right? So likewise, we now that was our initial data, these nine columns, and these four columns we generated from the given data. Okay, so that is the creating new features, right? As we said, if you remember, these columns are nothing but features of the data. So if we have we had nine features initially in our raw data, out of which one is E, which is dummy column, which created due to data processing. So we had a structured data. This structured data is created. It is not readily available anywhere in industry. So someone created this data, and that process, uh, that dummy column has been created. So uh, out of that raw data, we created four more columns. Okay, now let's see what we did next. Now we did mapping. So what is mapping? So if you see here, day of week, we have 3 3 3 3 3. So all that calls were generated in same day. So if I put some more, if I visualize some more data, oh, just reran it, the entire clock. Just wait a second. Yeah. Oh, still all the threes. Okay, no worries. You get the idea. So this is in numerical form, right? I want it to display the actual day format, like Monday, Tuesday, or Thursday, Saturday, whatever it is. So we did write a dictionary. So here we introduced dictionary, and we put the key and its corresponding value. So in dictionary we have words and its meanings. In Python dictionary we have keys and value. Essentially both serves the same purpose. So if I have zero somewhere in anywhere in my uh, program, I can map that zero using this dictionary to say it is a Monday, or MON, whatever you write it here, it will understand it is MON, right? Likewise, we mapped it here. So if you can see the day of week, we took the day of week column, and we map this dictionary dmap with the day of week column. And after this is done, the mapping is done, the result is restored in that same column. So whatever the previous uh, value this column had, it will be overwritten. Okay, so like we have 3333 here. If I run this piece of code, and if I see this, you see every three value is turned to thu, that is Thursday, right? So we did that, and that's where we left off, right? I guess uh, now what we need to do, I want to see the count plot of the day of the week column. Okay, and there is a term called hue based off the reason column. So we will see what is that. So if I want to plot the month of the count plot, what we should do, if you remember from the count plot here, here is the count plot. We pass on the column name, and it will count every unique values of from that column, right? So the column name here is df, that is day of week, right? day of week, and so that is my column, right? So I need to plot the count plot. Sorry, I need to count plot this column with hue as reason. Okay, so let's say I call the SNS, that is seaborne, and count plot. Then I pass on the column that I want to plot, that is my day of week, and where this column is. So the data is df. So in df we have this column, and if I just plot this thing only, let me just plot it. Let me just plot it here. If you can see it here, Thursday, Friday, and these are the calls, number of calls occurred in different days, right? So this and let me just put the palette here. Palette is equals to Redis. Okay, so these are the day-wise calls. Now, if I put hue here, what it will do, it will split every day. So it will take the day column, day of the week column, and count the plot. And inside that column, if I put another argument as hue, so it will and pass like reason. Okay, I pass reason here. What it will do, it will take every day's data and count individually the exclusive regions, okay, and plot it. So we just actually increase the resolution of each day calls. So initially we had the total count of a single day, like for Thursday we have a total count of Thursday. Then we just divided that total count. Out of that total count, how many of call occurred due to EMS, how many of fire, and how many for traffic. Okay, now if you see here, the legends here is overlapping with the plot. Okay, so to deal with that thing, what we will do, we will just type plt.legend and pass on some arguments. Just I will explain what each argument means. Okay, so anchor is equals to, let's just pass 1.5 and 1. Okay, then the location is equals to 2 and border access add is equals to 0. Okay, so if I just run it, you see it went outside of the axis. So what I did, dbox to anchor is, it is actually the this point, the origin of this particular legend box. Okay, and what will be the uh, location of this box? So it will be 1.05 from the left. So 1 is the total axis. Okay, that is 0 to 1. Okay, so if I put 1 from the left, so it would have started from here only. So if I change it here for your understanding, if I change it here, you see it started here. So I just wanted to make a bit more gap here. let's say put 5. It shifted to more right. Okay, and this one is because of the height, at which height it will start. So it will start at 1. So if I if I vary these two terms, it will accordingly vary the location of this box of the legend. Okay, and location 2 means there are 0 to 10 numbers of the location depending on where it will occur. Okay, so if you put a best location, it will find the best location out of this entire canvas. 1 is for left corner, 2 is for right, 3 is for middle. Okay, so from right it will consider these points, from left it will consider these points. So from where this location will start, to initiate that we pass this thing. Okay, you can go to this particular syntax and search it at matplotlib. Okay, and border axis pad, this thing is, that is the uh, gap between the legends and the box boundary. Okay, so I made it 0. If I increase it 0.1, 0.2, 0.4, let's say I make it 0.4. Okay, so the border actually increases or decreases. Okay, so that is not of very much of interest for us. So just the syntaxes I wanted you to know. Okay, if you don't pass these syntax, it will also plot. Okay, so let's do it for the month. Okay, for the month, what we will do? So we have this day of week. If I want to put it for the month, we just take the month column. Okay, so just same thing here. Run it. You see, for every month, how many calls occurred, and for each call, for each month, what were the reasons for the occurrence of those calls? Okay, that is divided into these legends, and what are the colors is represented by the legend. Okay, so if I ask you to do it for hour, you can do it. Okay, for each hour, which calls, which reason appeared. Okay, so that is the same thing. Now if you look at here, so the plot is obviously I took a sampled version. So in that version I didn't have any call values for in a 10th and 11th month, so it was not displayed. So I thought it would be better to plot it in other way. So I thought this will crawl. Anyways, we will see how to plot it in other way. Okay, so this is a count plot. If I want to plot it in a line plot. Okay, so how we should do that? Okay, so let's see that. Okay, okay, let me tell you one thing. When we use the count plot, I just want you to find out how we plot the line plot. Okay, so not everything I should explain, and you just watch. I leave it to you. If I want to plot not the hue part, just forget the hue part. I want to plot the month versus the count. In which month, how many counts are there? So if I want to plot it in a line plot, how I would plot it? Okay, so that is your part to explore. Okay, so I leave that to you. So let's move on to the next problem. Uh, Now create a group by object by month and see. So create a group by object called by month where you group the data frame by month column using the count method for aggregation. So what I mean here is uh, there is a month column. So there are several calls generated in month 12. You can see it here. So I will group all the calls generated in 12 months. Same for 11 months. Same for some other months, and will store it. Okay. So how will I do that? So let's see. So that is a problem. That is a demonstration of group by function. Okay. So if I create a by month variable. So let's just create a by month variable or group by object, if to say so, uh, and just pass the argument df dot group by, and I will group by which column. So I will group by the using the month column. Okay, and then I will count it. So uh, how many calls or how many data set we have for the month of one, for the month of January, for the month of February, and so on. So how many data set or how many data points do we have for each month? So if I run this, we have a by month object. So let's see what is the by month object is about. So dot head, if I display it, you see now the month 1, 2, 3, 4, 5, 6. If I just if I remove head and plot all the months, so you see these are the 12 months and these are the total numbers for different months. Okay, you may see a little bit of difference, like for this in month of February we have same counts of these columns, but we have a little less count of this column. This is essentially because some of the data is missing in zip column in the month of February. Okay, that's why somewhere you will see mismatches of the data. Okay, if the data is missing, it will not be counted. So once we have done this data set, creating the group by the data set, what I want to do, I want to visualize it. Okay, so I want to create a simple plot by the data frame indicating the count. Okay, so what I can do it here, I can do by month. So let's to plot it, I need to take some data. Let's take latitude. Okay, so eventually, ideally, all the elements should be same. Why? Because for the call, the latitude, longitude, description, and all the values data set should have all the values for every column for a call that is generated. So ideally, for all the calls, all the data should be same, but as there are some missing values, due to those missing values, there are some differences. So I would ideally take latitude. So if a call is generated, I am assuming the latitude is recorded. Okay, so I won't miss out of a call because of a variation of data. So I'm taking my latitude column as ideal. So I call lat, and to plot, to do a line plot, I will simply write the plot. If you can see, this is how the call from in different month varied. Okay. Mm, maybe if your data set which I worked yesterday, I guess that was a sample data set of the total one. So today it is the total data set. So this plot may look a bit different for you if that is a different data set on the sample part of the data set, but essentially you will get a line plot. Okay, that is what we hope for. So this is the value for first month, the second month it dropped, the third month, in month of March it went up, and in eighth month it dropped ridiculously, like from seventh month, like it is July to August, there is a huge drop. Then again it went up. So this is a trend which we can see in a given month, the call data. So see, by analyzing this data, we can uh, derive many things about the emergency calling pattern, the behavior of emergency calls that received throughout the year. We can draw out some patterns. Okay, we will explore more and we will see how exploratory data analysis helps. Okay, without applying any model. Okay, so let's just go on and now see if we can use Seaborn's LM plot. So LM plot is linear model plot. So linear model is what? To give you a brief introduction, linear model is we have some data points. So there are 12 data points here. Okay, so if we just if I take month and latitude, so there will be 12 values in latitude. So these are the 12 values. If I take these 12 values and put it in a graph, so this is my month and this is say my latitude, that is drawn with respect to TWP. We will show that too also. So if I take month and latitude and plot those graphs, plot those points, and want to draw a pattern, how a straight line that is that is the closest to all of the points, how it should look like. So let's jump into it without explaining it. So if you see it, you will understand. So SNS dot LM plot, that is the linear model plot, and then we will pass on the arguments. So what which column we are taking, which I mean which group we are taking? We are taking the month. So my x is month column, and what will be my y? My y will be, let's say, any other column you choose. Let's say land. Let's first uh, plot it with land. So I'm taking land. That is latitude. Okay, and then where these columns are, what is the data source of data? That is my by month. So I'm not referring to the original data. I am referring to this data set now. Okay, this is the by month what we have generated using the group by method. I am now referring to this data set and try to find out what is the pattern for every month. Okay, so data is by month, and then if you see one thing, if I am referring this thing here, so there is no column called month. Okay, see, there is no column called month. The month here, this is not a column, this is the index. So every data frame has an index. So this is an index. So I cannot call an index as an input. So what I need to do, I need to remove this from the index before call it. So essentially, if I call this, it will show in an nil. So month is an index. Okay, so I cannot call an index in my x values. So what I need to do, I need to reset the index. Reset index. Okay, let's first reset the index so it will be clear to you. Okay, let's first do this reset index. If I put reset index, okay, now if you see, after resetting the index, there is another index column added, and the month is now moved to a column. Now it is not an index, it is a column. Now we can use it. So either we can do it in a separate line and then call column here. Then if I call it here, then it will not. Then it will not show an error. Why it is showing error? Let me just check. X is equal to month. Data is by month. Y is lag. Not by month. So it's done. So when I'm calling the month, it should not be an index. So I reset the index while calling it, and then I I put it on the data here. Okay, so that is the latitude in my y-axis. That is my month in x-axis. So these are the dots. These are the values. So if the LM plot, the linear model plot, automatically tries to draw a line which is closest to all the values. But you see, these values are very much away from the straight line. So that is a linear model, linear line, sorry, cannot justify these lines, these dots. So the shaded area here, the shaded area shows the, if I use this line as the reference, so this shaded area will be the amount of error I am inducing to this assumption. If I think this is the trend that every month call follows, so this is this much of error I am introducing to that assumption. Okay, so this is what LM plot signifies. Okay, you can just change the y-axis to see if there is any better match. So it won't be much of a difference because almost all the columns have same amount of data. Okay, so this is it. You can just play with it. Now, as we have done this, so let's just create a new column called date that contains the data from timestamp column, and you will need to apply dot date method. Okay, so initially what we have done, so when I'm talking about timestamp column, I'm talking about the original, this file, df. Okay, so we have df. In df we have timestamp column. In timestamp column, I want to extract the date information. So how we will extract the date information? Using dot date method. So let's see. So if I use, let's say, let's just first grab one element from that column. So let's say d or date is equals to not date, it is a timestamp column. So let's take T. So it won't confuse you. P is equals to from a column called timestamp. What I will do, I will grab a single element. Okay, let's say the 0th element, and I will just perform dot date. Okay, you see, because I converted this column from string. Sorry, where is the original? Yeah, this is converted from string to date time, so I can extract the date from the entire string. So what will be the syntax for that? I just pass on dot date. If I pass the date dot date method, it will extract the date from the entire date time object. Okay, now this is for a single element. Now I want to apply it for the entire column. So what we will do? Obviously, we will apply lambda function, right? So for lambda function, so let's just add another cell here. Okay, so the lambda function would be df, grab the column, that is my timestamp. Okay, then use dot apply, then apply the lambda. So what will be my lambda? So the syntax, the way of using lambda is you just initiate a element name that is, let's say, x, and that I will perform some operation, and that operation is dot date operation. So I want to extract the date, so that will be my lambda function. So this is my column, this is my function applied on each element, and what I will do with it, the output, that is essentially will be some date, I will put it in a new column. So let's name the new column df date, right? Let's just what went wrong? Let me see. Key error timestamp. Okay. Okay. So that is a capital S. So hopefully this will run now. It is running. It is operating the lambda function. It is applying this operation and extracting the date and filling it into a new column called data. It is done. So now let's see if I have. Let's just put it in a new df dot head. As you can see, we have a new column called date. So this is my 1, 2, 3, 4, fifth. This is my fifth feature I have extracted from the given feature, right? So this is how I extracted date. Now what I will do, I will group this column, group by this date column, and plot it. Okay, so there are different number of calls generated each day throughout the year. So I will plot the date versus number of calls. Okay, so I want to do that. So to do that, I need to group the entire data set by date. So I want in this date how many calls, how many rows. In this date how many rows. Oh, okay, these are the two same dates. So in these dates, let's say 1, 2, 3, 4, 5, and more. So if there is more calls in this date, so it will be grouped into one column, and it will be given the number of the counts. Okay, so let's do that like we did it before. So how we will do that? So, using group by method. So in group by method, what we pass? In group by method, we pass the column we want to group by. So we want to group by date. So we passed it, and then we want to, after grouping, we want to count the number of calls occurred. Okay. Now let's see it. So I am putting dot head along with this. Okay. As you can see, there are 114 calls originated on 10th of that is the day, 10th of December, right? Similarly, there are different dates, these are different numbers. Now, when I have this group by thing, what I want to do, I want to create this plot, but create 3 separate plots with each plot representing reasons. Okay, now I have this. So what I'm trying to say, I have this number of calls originated. Now I want to see in 10th of December. Okay, I know 114 calls originated. Now I need to know, out of this 114 calls, how many calls are for fire reason, how many calls are for EMS reason, and how many calls are from traffic reason. So how will we do that? Okay. So we are just exploring every possible aspects of the given data set, right? By visualizing it. So the best way to explore the data is to visualize it. So let's just try to create it. So I want to group by date, right? So df group group by, and then I pass the column date. Now I don't want to group all the df. Okay, now my focus is I want the separate reasons, only the reason, like I want to see for how many calls are originated for traffic. So I will pass here. So I will pass from df, I will pass only traffic. Oh, sorry, traffic. There is no column called traffic. The column name is reason. So I will pass the reason column, and I will pass it saying if the reason is equals to traffic. Okay, I will repeat it again. So I am grouping by date column. Okay, so I'm grouping by this date column. Here it is the date column. I'm grouping by this date column this entire data set. Firstly, I grouped it first in the entire data set. Now I want to group it only by the reason column, and then also I want to see when the reason is equals to traffic. This is a Boolean condition. When reason is traffic, when this condition holds true, then only the date it will be grouped by. Am I making any sense? Okay, I will repeat. When the column reason satisfies the condition of being traffic, then only for only those elements it will group by date. So for a particular date, the number of traffic as a reason occurred, it will be grouped, and then we will count it. When we will group, we will just put a count. Okay, now when we counted the thing. Now we want to plot. Okay, so if I want to plot here, like we plotted something like that, no? Grouped data. Plotted here by month. So when we plot, we counted here. So you see, by month, first we grouped here. So that this in this line, I just went line by line. So first we counted here, we put it into a variable. Okay, then we called the variable and called a special column of that variable and plotted it. Now what I want to do, I don't want to waste any memory to ho- hold it in another variable. So what I will do, I will directly uh, where okay. So I will group by the date. I will count it. Then I will call a column which I believe have all. Then there is no missing value. So that is lat for me. So I will call lat, and then I will plot it. Did I made a mistake? Is there something? The reason. Okay, let's just change the reason. I guess it is capital T. You see? So it is a huge data from 2016 to 2020, right? All the dates are plotted. For each date, how many calls are generated? So you see in 2018, there are some peaks. Okay, there is a very high call. Number of calls per day went beyond 1200. So maybe there were some disaster in these dates. Okay, these high calls. So we can conclude from this thing. So something happened, something wrong happened in these 2 days or in nearby days. Okay, let's say for 2, 3, 4 days continuously, there are more number of calls. So we can visualize it from here. And if you just got lost in this entire syntax, you can break it down. Obviously, you can just write, let's say, by date is equals to, you put it here up to this. Okay, then you call by date and you call a column from by date. Okay, let's say lat, and then you plot it. This way you can also do the same thing. That is the same thing. I just made this in a single line. Okay, so if you are having trouble to do it in a single line, obviously in time you will get used to it. Okay, but if you are finding it difficult, you can just break it down to single lines, and then you can obviously plot it. Okay, now I encourage you to do this with month wise. Okay, let's just add some title. Title is equals to here. The reason is traffic. It's just uh, so see, uh, this is traffic. If you can, if you want to change and to be more specific, the reason for those calls are, the reasons are traffic. So I guess if I want you to draw a plot using for the cause of EMS or fire, you can draw it for fire and EMS. Okay, I guess you can do that. Okay, there is another thing. Let me just draw it here on it so that you can see. If you put region, group by date, and okay, so far so good. Now, what I mean to say, if there are overlapping uh, tick marks like the 2016, 2017, these are the ticks, X ticks and Y ticks. So maybe there may be a case when it is overlapping. Like see here, there are almost very near to it. Okay, so if you see there is an overlapping case, okay, let's just find out if there is an overlap. I can find, so I can show you right away. No, it is only showing the date. Sorry, the years, so it won't overlap. If it overlaps, or if it doesn't, even if it doesn't, you just type what was the tight layout. I just forgot the tight layout. Let me just see. Ah, layout type. It's not layout, right? It's tight layout. That's what I tight. Okay, so it will distribute it evenly, the X ticks and Y ticks. Okay, so it is very much advisable. It is a good practice to always put tight layout whenever you are plotting anything. Okay, so it will put your X ticks and Y ticks and the fitting of this curve or this signal or the data evenly distributed. Okay, so I hope you can do it in case of fire and EMS. So I am not doing it here. Okay, it is essentially the same way. I already have done fire, right? Okay, I guess it is fire. So you need to change the title also, right? Remember that. Now let's move on to the next task. Now we will create heat maps. So what is heat map? Heat map is the representation. Uh, this is how it looks like. It is a representation of the data in a colored way. So the color represents the a scale. Okay, so this is the scale. The blue means a low number of no low number of calls, and eventually the change of color represents different numbers in the scale, different level of the scale. Okay, so what I say now, let's create a heat map with Seaborn and restructure our data frame so that the columns become the hours and the index becomes the day of the week, and we plot it as a heat map. So what I want to see, uh, for like for each day at what hour how many calls are generated. Okay, and for throughout the years for each day how many calls have been generated. So what is the pattern? So hourly for each day throughout the entire data set or entire years. Okay, so to do that we will use unstack method. Okay, so what is that unstack method? So first we will Let me just stay along with me. I will explain you. Let me just first write it down. What was the name? Day of week, I guess. Yes. Day of week. Then we have hour. Then we dot count. Then we do dot hour. Sorry. Then we will go by the reason. Let's go with reason, and then unstack it. Okay, and let's just put it in a new, what is it called, data. Okay, so what I have done here is, till now I was grouping the data by a single column. Like for here it is date, up above we grouped by month, I guess. Okay, the reasons. Now I want to group it using two columns. So I will group by day of the week and the hours. Okay, so I using two columns and group using these two columns into one single data frame or one single object, that is day hour. Okay, and putting count. So I'm counting all the what I can say, all the columns, other columns like latitude, long. What is the count of the latitude if I group together using day of the week and hour? If I what will be the count of the longitude, the description, the zip code if I group using day of the week? So likewise, I grouped it using the entire. Okay, let's just first do it. I won't go in a single line. Okay, you see, uh, if I group it in a day of week and hour basis, so see, this is a day of the week, this is grouped, and this is hour. For single hour I have this many calls. In Friday, so this is 1 hour, second hour, third hour, fourth hours, and up to 24th hour. Okay, so Friday we have these many calls in these hours. So this way it will be grouped. So you see how this looks like. Now if I when I have this group, okay, the counts of individual columns, now I want to extract only the reason, this column. Okay, now I want to see only this column. So reason. Now you see, if I put only reason, all other columns are left behind. So I only have reasons, count of reasons for Friday from 0 to 24th hour, for Wednesday, Thursday, all the days. Okay. Now, if I want, so let's just put it in a day hour, what we did previously in a separate variable. Now, if I do unstack, what it will do, unstack will just spread this thing. The hour will go to the columns. This will become our column. This 0 will be my first column, and this will be my rows. Okay, essentially how it will look like. Okay, let's just plot it. If I just plot it day hour, you see, now these becomes my column, and the weeks, day of the week becomes my rows, and the counts are distributed for each hour. What is the count of reason? So I divided the count reason for each hour. So this is the unstack. This is the job of unstacked method. Okay, if you finding it hard to follow, you can always go using for loop and other methods using pandas. So I encourage you to find other methods also, but you can always check this method. Okay, unstack all the documentation you can read, and you will find how this works. So I try to explain it step by step. First you group it, you see how all the columns are grouped using these two, then we counted it, then we extract only single column, and then out of the counts in that column, we spread it over the 24 hours. Okay, now it's time to plot. It's time to make the heat map. So heat map is very simple syntax to plot the heat map. It's just heat map. Once you have the data, you just pass the data. Called SNS heat map. What was the name? DR. So this is the heat map, right? Now, as I said, I like the Veritas palette. This time I won't misspell it. Veritas. Again, what happened? Oh God. That is not the right thing. I mean, here, what happened there? Let me just see the quad mesh has no property palette. Okay, okay. So this is heat map. Mapologies. It is not palette here. It is the C map. So these are different in different methods. These color maps are called differently. Okay, this is my color. So in case of C count, it was palette. In case of heat map, it calls C map. Both serve the same purpose. Okay. Now this figure, if I want to enlarge this figure window, what I will do? I will just call a larger figure window and plot it. So I need to call the window before I plot it. So I just call it plt.figure and say the fig size is equals to, and pass on the width and the height of the fig size I want. So I want 12 by 6, 12 on 6. Okay. You can use it comma, or you can use like this. Okay. Now you see it is enlarged. You can play around with the fixed size and see how it differs. Okay. Now essentially this in this data, you see that this is the day of the week. These are the hours the call generated. You see from uh, 12 a.m. 0 a.m. up until 6th, up until morning 6 at the morning, there are very few calls. Okay, then the call generally increases, and at uh, 4 to 6, especially at 5 o'clock, the most number of calls are being generated. And if you see it row wise, the Saturday and Sunday, these 2 days, the number of calls are relatively less as compared to other days. So this is essentially what heat map says. Okay, so let's just do the clustering. Okay, clustering is nothing but it will see the similarities between these rows and columns, and it will group it together. Okay, so how we will do the cluster? So it is also same straightforward cluster map. They are, and my C map is what it is. Now you see 0, 5, 3, 4, 1, 2, 6. So these are the clusters. So it how it clusters, it takes 2 arguments at a time. So it will take 0, 1, 1, 2, 0, 2, 1, 3, any 2 arguments, and compare the similarities. Okay, the values. If the values are same, so these two are compared, these two are the most similar, so it was grouped first, then and then these two are the similar. Okay, so now the similar groups are grouped together, then it is compared to another group, then the likewise it will group all the data and present. So there will be a little different from the heat map and the cluster. It clusters all the similar data. Okay, now I want it says repeat the same plots and operation for month column. Okay, so I have done it for the date column. I want you to do it with the month column. I guess sorry, day and hour column I have done. You do it for day and month. So in case of 0 to 24, you will have 0 to 12 or 1 to 12. Okay, so then you will plot it here. So it is just the same thing, heat map and uh, cluster plot. I guess you can now do this. Okay, and I encourage you to do more exploration. The more you do, you will learn more possibilities how you can look into the data and bring some insights to it. Okay, so from here we can initially say that this time, this duration of time, the number of calls are high, the expectation of a call is high. In this fire, and these are some peaks, right? So June, May, Jan to Feb. Between Jan and Feb, there must be some issues. There are some fire issues, we can say. In Okay, this is also fire, so I essentially change it. Let's change fire. Okay, something happened in this time, so the number of calls is high. So there are some insights we can draw from this exploration. So I will stop it here, the exploration part. Okay, and now I would like to take a few questions, 5 minutes, then we will move on to the next part. Okay, so if there is any question. Do anyone have any question regarding this thing? Okay, so let's just move on to the next part, which is the terminology. So let me just switch the sharing. Okay, so we will now move on to some terminologies. Okay, what are those things? And we will briefly discuss each of them today. And then once we are done with those terminologies, we will move on to the model design tomorrow. Okay, so the next 2 day will be model design. So first, let's see what is the bias and variance. I guess I'm visible to you all. The page is visible. I guess it is visible. So let's roll on to this terminology. Let's just clear it one by one. First of all, let me just do just share my tab. Okay. So let's see what these things are. What is bias and all that. So in case of machine learning, when there are data, as we have seen in our exploratory analysis, so data can be spreaded among all over the place, right? If you are plotting against two features, the data can be plotted among all over the place. So essentially, what bias means, bias is the difference between, and a model is tries to predict the data given the training data. The model tries to predict a new test data, which is new to it. The model didn't see it beforehand, and it tries to put it in a right place. Okay, so the bias is the difference between the predicted value by a model and the correct value. Okay, so being high bias means it will give a large error, and being a low bias means there is a low error between the predicted and correct value. Whereas variance means the prediction of the model and the actual value of the model. So it would be better if I just explain you with a fair example. Okay, so let me just see. So let's just assume we have a data which have two features. That one is height, another is weight. Okay, so when the weight increases, eventually the height increases, but after a certain time it falls down. Okay, so if I want to try to draw fitting curve to it, it will look like that, right? Now if I go for a straight line, for something like when I train a model, let's say the model predicts the line, the relation between height and weight is something like this line. So let's say this is the model prediction, model hypothesis. This could be the actual relation, right? So if I have a model having this hypothesis, so for this data there is a large amount of gap between the predicted value. So what this data essentially says, if the model is trained using this line, it means if my model have this line, okay, so that means given a weight, let's say I have a weight here, so the model will tell me the height of the particular person is this much. Okay, it can be true that the actual height of the person is this. So there is a gap. So this gap is the error, or it can be a possible case when my weight is this much, the model by this hypothesis, it will tell me uh, this this is the height of the person, whereas the actual height of the person is this. So there is an error. So actual height is this, the model is saying this, so this is an error. So this error, that is, if I know that model has this much of error and I let it be, for the sake of prediction, this induced error is called bias. So this is the gap between the predicted value, this is my predicted value, and this is my actual value. So the gap, the difference between the prediction and actual value is bias. Okay, so the less the error is, or the less the bias is, the better the model will be. Okay, now see what do we mean by variance then? Now let's say if this is the same data, now I prepare a model with the data. Let's say okay, first of all, just let me just split it into training and testing. So this is my training data. Okay, these are my training data, and this is my, so it will be more clear to you. This is my testing data. These data will be used for testing. So if I design a model in such a way, there is no error. So let this also training data. So the model, let's say, fits all the training data. Okay, so if this is the case, the hypothesis will look like this. Okay, now there is no error. If I see the training data, it actually takes the actual value of the card, right? Actual value of the training data set. Now, when I try to fit it in the training test data set, what it become? Now, if I say this is my weight, according to the hypothesis card, it will look and it will say this is the height of the man. If I say this is the weight, it will say this is the height. Whereas here in first case 1, this much of error occurred. In second one, this much of error occurred. In third case, when the height is here, it will say this is the height, whereas actually height is here. So this much of error occurs. So the occurrence of error varies from point to point. So see, the weight is increasing very linearly, but the height is not varying accordingly. So it is varying very vastly with respect to the actual value. So if this error varies very vastly, that essentially means this particular model has a high variance. So if I want to summarize it, if I want to try to justify all the training points, then eventually my complexity of the model will increase, and it will not fit the testing unknown data. The unknown data will be misleaded as something else. The actual output will be something else that will have a huge error. Whereas if I have a simplified data, okay, where I have a simplified, if I say I have a simple model, in case of training, I actually allowed this much of error. Let's say these are the training. I actually allowed this much of error. I know this model is errorless, but at the time of prediction of the test data, it also have a tolerable error. So it will perform not very good, but it will perform okay. It will predict the model okay. So this is a trade-off. So how good I want to fit the data in training is a course of action that will eventually decide whether my model will be having very high variance or not. So there is a trade-off. If I just put if I want to maintain a low bias, that is less error, that means this model like this, there is a chance we will have high variance. Okay, if I say okay, I will keep it very straightforward and put very high bias. If I put very high bias, so eventually let's say this is my very high bias. Every point is very far away from the data. So eventually the model will fail. Not even the variance will not occur because the model itself trained with a very high error. So there is a trade-off how much of bias you can induce so that you can have a low variance or a tolerable variance. This is called bias variance trade-off. Okay. So I guess bias and variance is clear to you. Let's just move to the overfitting and underfitting. Okay. With that context only, let's say I have this much of data. In that particular height weight data set, I have this much of data. So if I train this much of data, the data set, the training output, the model will have this like this of this much of curve. Let's say this is my hypothesis for this much of data. I don't have this many data. These are the there are no training data from these points or this sector. Okay. If I have less amount of data and I train it and I build a model, if there is other set of data from where there is no data points in my training data, so I don't have a weight. Let's say this is my 0 to 100. So I trained the data having my training set having data weight up until 0 to 60. So if I put a data of let's say 75 kg weight, it cannot predict it. It will predict very wrongly. It will say the height is over 10 feet, which is not true because at time it bends. So I don't have the data set. So it is not the less number of data. It is the range of the data. So I should have all the range and sufficient amount of samples so that it can train upon. If it is not the case, then it is a case of underfitting. Okay, so you got the idea of underfitting. And overfitting. Overfitting is much discussed value. If the variance is high, if I train the data too much, it will try to fit all the training samples without any error. And in way of doing so, and testing data, it will induce a huge amount of error. So the result is, I will say, it performed well in training, but when I give it a new data, the test, it performed very badly. So this is overfitted. So the data, the model is overfitted by training. So this is called overfitting. Okay. Then we need to do some methods that are called feature engineering. So that is the next part of our talk. So features, what are the features? We essentially know the columns are the features, and feature engineering, we apply some statistical tools, some calculation to make the data more insightful, right? So this is my feature engineering. So what I have listed 6 feature engineering processes. There are a lot feature engineering process, a ton of processes you can do, out of which I just try to point out some basic features, the feature engineering process. So first of all is handling missing value. So there are 2 ways of handling missing value. Okay, so I have I have given you the description along with the code. Okay, what can be the probable code? So if you set a threshold beyond which, if there is a value, oh sorry, I'm talking about missing value, you just call dot is null. So if you see here, sorry, if you see here, data dot is null, it will give the, if there is a null value. If it is a null value, you can do 2 things. Either you can discard the rows or column, or you can put another value in place of this empty shell. Okay, so you can do a 0 or constant 1 or 2 or 3, whatever constant value you want to put, or you can do mean, median, or mode. So you can apply this value. So how you will do that? So first you want to see how in a particular column, let's say, what is the mean value of the missing value. Let's say it is very good practice to discard the entire column is 75% of the column consists of missing value. So there is no meaning of keeping that column because 75% of the column doesn't have any data. So we will just discard it. Same with the row. If I have 75% of the element in a row missing, there is no data. So what is the point of keeping it? So we can just directly discard it. Okay. Next is, if I want to, if I don't want to discard it, no matter what my value is, if I don't want to discard it and I want to replace it with something else, you can replace it with 0. So that is the formula dot fill na. You can replace it with median or mean or whatever you want. Okay. So there are several ways to replace it. However, median is the most preferable way because it does not affect the distribution of the data, right? Okay, categorical. So there are two type of data, right? If you have seen, you have seen it in our data set also. So there is numerical and categorical. Numerical data consists of several numbers. Categorical data consists of several different objects or different categories. Like it can be a name of country, it can be name, it can be your month, okay, day of week. These are the categories, and numerical is the numerical value. There is nothing to explain. If we have a categorical column, okay, so the best way, the best practice to impute the categorical missing value is to find the maximum occurred. So if in this column, let's say 1000 rows are there, and in 1000 rows, out of this 1000 rows, 500 rows says it is Monday, and there are 100 rows that are empty, and other rows are distributed between 6 other states. So these empty columns can be filled by the most occurred rows, that is Monday. So I will fill it using Monday. So that is a practice. So this is essentially also the median value, right? And if there are uniformly distribution, okay, so there are also, that can be also a case like there are 1000 values, okay, so 500 are Mondays, 100 are missing, and let's say 20 are Friday, 60 are Saturday, like that. So with respect to this 500, these are very small values, so we can always group together and keep it in a category like other. So it is a good practice to put small the categories with small counts in a group and name it other. So this is a practice that is used in before training the model. Okay. Now outliers. What is outlier? Outlier is a unexpected value in a data set. Okay. Let's say this is my daily routine, and unexpectedly I did that. Okay. So this is an outlier. This point is an outlier. I am not supposed to do this. Okay. Or this is how much I ran. I run every day like 1 kilometer, and this day I run 4 kilometers. So this is outlier for me. I don't run it, something happened. So this should not be considered in my training data set. It will destroy my training. Or if I have like 2-3 such outliers, so it will destroy the entire data set. So I should get rid of those outliers. So how should we handle the outliers? That is a vague example. It can happen in any way. Okay, so the outlier, the best possible way is to first visualize, like I just plotted. You can understand how what are the outliers. Okay, and then once you see the outliers, you can just apply some tools to remove it. However, there are statistical tools also. Okay, the statistical tools also can be precise, can may give unprecise results also, but it is fast. So the best practice is to visualize the data and see whether there is an outlier or not. And if it happens to be there is an outlier, then we perform some operations. Or to detect the outlier, there are some tools like using standard deviation. Okay, so we multiply the standard deviation with a factor. So let's say x, here I have taken x equals to 3, and if the value is beyond this value, then it considered as an outlier. So upper limit, the column mean plus the column standard deviation into the factor. The lower limit, the column mean minus the column standard deviation into the factor. So you can create these formulas. Here I said the factor is directly multiplied with the standard deviation. Here I have done the mean. I have added the mean to increase the upper limit. I have subtracted the mean to give it a lower limit. Okay, and the data in between these two limits is considered. So this way you can get rid of the outlier. Let's see. Okay, you can put the quantile. Okay, the 95 and 5 quantile, let's say, out of the data. Sorry. Out of the data, you will just keep, this is the 100% data, you will just keep from 5% to 95%. This much of data is outlier, you consider, you can call that. Okay, you can just drop it off, chop it off, this data is discarded. Or what you can do, this data is capped as this point. Okay, so if let's say I train a model with a feature x as edge, so I will cap the edge from, I want the edge to be between 5 to 60, or let's say 15 to 60. So any edge less than 15 will be treated as 15, and any edge greater than 60 will be treated as 60. So this is called capping. What is the benefit of capping? The number of data points will remain same. Okay, so if there is a if you have a data set with a low number of data samples, you can cap the data. Okay, next is binning. So what is binning? The same example, let's see. It is a grouping. Like I have some feature x which varies from let's say 40 to 70. Then I can group it into several groups. Okay, there are 4 groups shown, that is 40 to 50, 50 to 60, 60 to 70, and 70 less than 70. Sorry, greater than 70. So I can create n number of groups. The number of groups will be decided by me. So you can create these groups and put it into same group. Now, what is the benefit of this? Now, when you train the data using a group, there is a less chance of overfitting. Okay, and when you say it is a group, then the performance will be applied on the same group, all the group members, right? It will be affect the performance also. Okay, so there is a trade-off between performance and overfitting. The next thing is one hot encoding. So one thing we need to know that while training our model, the model does not accept a categorical data. It only accepts numerical data. So numerical data only. Okay, so we need to convert the categorical data into numerical one. So how do we do that? So that we do it using one hot encoding. So what is one hot encoding? Let's say we have a data, and in that data we have a column called color, and in that we have these many of. So I have red, I have yellow, I have green. So there are three different categories. Three different unique element in this column. So columns, three unique elements. It will be treated as this. Okay, so this may be treated as red, this may be treated as green, this may be treated as yellow. Okay, so if there are four, so there will be another. So it will be like this: 1 0 0 0 0 1 0 0 0. Right? Let's say it will be blue. So depending on how many unique elements we have, we can encode it using one hot encoding. This is one hot encoding. Okay. So how can you do that? You can just write pd.getDummies. PD is the panda. So getDummy is a function, and you put the column name. So the number of unique elements it has, it will transform it into one hot encoding like this. So if you have, let's say this is my column, it will transform like this. Red is 100, yellow is third 011, and green is 001. Okay, I hope one hot encoding is clear. So now if I put this into training model, it can understand. Okay, so 100 is, that means it is a red. Okay, so this is how we make system or the model understand what is the categorical model is. Okay. Next thing is feature split. So we already have done that. Remember, we had a column called title. It has EMS colon something something something, fired colon something something something. In that, from that feature, we split it and created another feature called reason. EMS, fired, and what was the other one? Traffic. So this is a great way, and we have seen we have done many analysis on reason. Okay, so we introduced lambda function, we introduced split. Okay, so it is already introduced to you. So this is a part of feature engineering. You must know, you have already done feature engineering, some of it. Okay, scaling. Scaling means normalization or standardization. So to scale a data, we essentially, what we do, we create a scale, let's say 0 to 1, and we put all the data into this scale. Whatever the value it is, irrespective of the value, it will be mapped into this scale. So how we map it? A value x will be mapped using x minus the minimum value in this data set upon the maximum minus minimum. Okay, so this is the normalization formula. You must already know that. So we applied it, and the transformed value will be stored as a normalized feature, right? So here it is an example. Okay, let me just hide it. Okay, So this is a normalized feature. So here is the data, the value, and the values are normalized here. Okay. Another way of scaling is standardization. So this is a z-score standardization. What is a z-score? It is derived by the value minus the mean divided upon the standard deviation. Okay, so this is another formula using which we can scale the data. These are all the statistical formulas, and the below I have tried to describe what could be the possible code. Okay, so the data value column minus the data column mean. So this is the mean, this is the value, and this is the standard deviation, the division. Okay, so I hope this is understandable, the code and the formula. So how you code the formula. These are the examples. Okay, next next we come to the model validation and performance. So we are done with the data preparation a little bit. Considerable chunk of data preparation. Now we skip the model and we find if the model is trained, what are the how the model is trained. So the first thing is the validation, cross validation. Let's say I have a data set having 100 data points. Okay, so it is a best practice to keep 25% of the data, that is 25 points, for testing or validation, and 75%, that is 75 here, for training. Okay, so let's say I divide it into 4 parts. So my data is divided. Let's take this example only. The data is divided 1, 2, 3, 4, 5 parts. Okay, and this fold means, this validation fold means, this part of the data is holded, and this is the part of data using which we train the model. So training fold means the data is used for training, and validation fold means it is holded. And once the training is done, this part of data fed into it, which the model didn't see it earlier, and try how good it predicts this part of data. So this is performance 1. Then we move on to the next part, and the second part of the data is holded, and these 4 parts are given as training. Likewise, we do it 5 times here and calculate the performance for this folds, for this unseen folds. Okay, and we segregate the performance and the output of the data. Okay, so this is 5 times. This is called k folds. You can increase or decrease the k. It is a best practice to have 10 folds at least, okay, to validate your data. Apart from that, it is the actual practice, what we in industry, what is being done, the data is separated in 3 parts. Okay, so this is my modeling part, and this is my testing part. Okay, in this modeling part, then again it is split into 2 parts. This is my training, this is my validation. So once we are done, once we separate in modeling and testing, this part is kept aside. It is never used for even model or for validation. This part is used after repetitive modeling and validation. Once the data is giving a desirable performance, then this unseen data is used for final testing. Okay, so this is how it is done industry. So they divide it into 3 parts. Okay, and the last thing is the most important thing for a model to evaluate its performance is the confusion matrix. Okay, so it is just the matrix of what actual thing is and what the model predicted. Okay, so let's say mm, uh, whether a patient has cancer or not. Okay, the report of cancer either can be positive or can be negative. Okay, this is a binary result. Okay, and the model predicted the result as positive or negative. If the cancer is positive and it is predicted as positive, it is called true positive. If the cancer is positive, actually the patient is actually positive, but the model predicted as negative, it is called false negative, because it is saying negative but it is false. Okay, if the class is negative, that means the patient does not have cancer, but the class model predicted is as a positive patient, it is called false positive. So and if the patient is negative and the model predicted as he doesn't have a cancer, then it is called true negative. So this diagonal is for right prediction, this diagonal is for erroneous prediction. Okay, it also called type 1 error and type 2 error. Okay, somewhere I have seen so many guys get stuck or get confused with this term, true positive, false negative. Always remember TP, NP, these terms. Okay, when you say TP or NP, so T and P, the left side is for actual and the right side is for prediction. This is for model. Let's say model is always on the right side and the actual is always on the left side. So if you see it that way, if the positive is specified as positive, so this is the actual thing, it is positive. If it is not positive, it is said false. If it is positive and it is predicted as not positive, it is says false. Okay, if the actual class is negative, it says F. If the actual class is negative but it is considered as if the actual class is negative and it predicted also is negative, then minus minus, it's may sorry, this one is true. So just bear it in your mind that the prediction always holds at the right place, I mean the right side. Okay, so true positive means the class is predicted positive. True negative means the class is not predicted positive. There is an error. And false positive means the class is false but it is predicted as positive. True negative means the class is negative and it is also predicted as negative. Okay. Now using this thing, we can calculate so many things like sensitivity. What is sensitivity? With example, it will be clear. Sensitivity is the measure of positive examples labeled as positive. Okay, so the positive examples, let's say this is a example of a spam and not spam. So email is spam or not spam. Okay, so the model is trained and the given for a test set, it predicts an actual spam as spam and a not spam also as a spam. So this is the prediction of spam that has gone positive, and we have to see how many positive examples are actually labeled as positive. So this is calculated by the actual predictions that gone right divided by the total right predictions. So 45 divided by 45 plus 20. If you multiply it by 100, you will get the 69.23% of sensitivity for this particular model. Okay. So sensitivity is like true positive divided by true positive plus false negative. Specificity. What is specificity? It measures the negative examples labeled as negative. So how good it can predict the negative thing as negative. Okay, so that is a negative thing. It is not spam. So it is actually detected as not spam 30 times, and the error occurred 5 times. So if it was actually a spam, but it detected as sorry, it was actually not a spam, but it detected as spam. Okay, so for the negative case, we do the same. The true negative divided by the total negative prediction. Actually, what was the negative and the total negative prediction, that is 85.71% for this particular case, right? Next is precision. What is precision? The ratio of total correctly classified positive samples and the total predicted positive samples. Okay. The predicted correctly classified positive samples. So this, that means two positive correctly classified positive samples and the total predicted positive samples. So predicted positive samples are these one. The total predicted positive samples are 50. Actually classified actual samples that are positive is 45. So 45 upon 45 plus 5. So 90% of the precision. This model has 90% of precision. And what is the accuracy? Accuracy is the total number of positive prediction upon the total number. So these all are predictions, and positive predictions are, I mean, the right predictions are these two. The positive spam is predicted as spam, and not spam is predicted as not spam. So 45 plus 30 divided by the total number. So that is the 75%. So this is the accuracy. Okay. So I guess these are all the necessary terms. Okay. So that would be all, I guess, for this today. And if there is any doubt, one can always ask. Underfitting and overfitting. Okay. Let me just. If you see here, this is a simplified linear curve, right? So if the number of sample is less, okay, so this line could have been like that, right? So there is a less number of samples. If there is a less number of samples, the training data is less, and the range of the training data does not contain all the possible ranges. So in that case, if I restrict it from 0 to 6, the data from 6 to 10 is not available at the time of training. Then if there is a data at the time of testing that have a value of 8, 9 or 10, it will be predicted very wrong. Okay, which is not the case because we don't have the data. So if the data size is less, and or the data range is not covered the whole range of the possible feature set, then the prediction will go very wrong or the model will perform adversely. This is underfitting because of the lack of the data. And overfitting means if we train the data over and over again to have very less error. Okay, in this case there is no error. The model is trained for every data. It remembers every data, and when the test data comes, say let's say this is a test data, the model will predict for this much of the for 5 it will predict this. Okay, as per if the model was right, it would have predicted as 0.7. Oh sorry, it is not 5, it is 10.5. So the good model would have taken it as a 7, but because it is trained so hard, so it is trying so hard to fit in, it actually ends up predicting with a very large error. So this is called overfitting. Okay, so we should not try to fit all the training points. We should leave a scope of a margin of error, which is called bias. So we induce some bias in order to keep the variance low. If the variance is low and the bias is considerably low, then the data won't overfit. Okay, I guess that answers your question. Okay, if there is no other question, I would like to call it off for today. And tomorrow we will be discussing about the models. Okay, so there will be 4 models in today. We will be discussing it. So I guess that would be all. Uh,
Yeah, thank you, Snashish. I think that's all for today. We'll meet again on tomorrow at the same time.
yeah.
Okay. So Shoktik, I think you have already turned off the stream.